Hi everyone. I'm Kaz, the instructor of the course. So can you turn on the videos if you can, if you cannot, that's fine. But yep. Hi. Okay. So welcome to the STAT 5030, the statistical computing and the data analysis. So let me introduce myself. Yeah. So I'm a statistician. Actually, I got the master's degree in mathematics when I was younger. Then I got a job in a bank, and I did some statistical analysis, mostly the macroeconomic analysis and also the business survey design. And I worked there for 4 or 5 years. Then I went to the PhD program in statistics in Wisconsin. Then after that, after finishing a PhD, I came to Wayne State to teach. So I have both the theoretical and the applied the background in statistics. Yeah, maybe I would like to discuss the syllabus first. Then after that, I will make some survey about your backgrounds. Then after that, I will set up some breakout sessions today to introduce yourself to other classmates. Then after that, we will enter the chapter 1 of the textbook. Do you have any questions before starting? I think that I have seen many of you in other classes, maybe not many, but at least some of them. Yeah. Yeah, I think I have seen I think the Claudia that you did take my course, right? So before, and then maybe Kirsten Adams, maybe, and some here, Jason, and yeah, I think there's some others as well. Okay, so the syllabus is available on the website, so you can see, but I will share the screen to make sure that you can see the contents. Okay, so this is the syllabus. Can you see the syllabus? Okay, good. And yeah, so this course is the online class, the online synchronous class. And yeah, my name is Kaz, and when you email me, you can use either my Wayne State address or other Gmail address, the seikibunpu@gmail.com. So this word means normal distribution in Japanese. And the course website, we use the Canvas, and also I will upload the lecture videos to YouTube. And the lecture Tuesday, Thursday, 6:30 and 7:45. Yeah, hopefully I will have some exercises during lecture. So the course was designed when the lecture time is longer than now. So it's a little bit hassle to include the exercise. But this year I will try to shorten my lecture time to give more time for exercises. And the office hours, the Monday 11:30 to 12:15 in my office or in Zoom, and also Tuesday, Thursday 5:30 to 6 p.m. So Monday, I have another lecture from 10 to 11:15. So sometimes I'm late for the office hours, but just wait for maybe 5 minutes, then I will appear. And the prerequisites, the STAT 2210 and the Math 2250. So basically, the basic statistics and the basic linear algebra. So I think the both are really essential to take the course. So you know, if you are not sure if you are fine to take the course, just let me know. And are there any students who have trouble to register for the class? No, then probably you cannot really enter the class. But anyway, yeah. So if you are a graduate student and has some trouble to register for it, then just let me know. And the textbook, the Peter Dalgaard, the Introductory Statistics with R, second edition, that you can find this book on the website. And this book is an applied book, so I will supplement more theoretical materials, the theory on statistics in slides. So I think mostly the slides are self-contained and they're more comprehensive than the textbook, but sometimes it may be helpful for you to download the textbook and to see it. And some references, the several books on how to use R and also some theory, the statistical theory. And the first book is probably more comprehensive than the textbook. So for self-study, maybe this book is better than the textbook. So it's a heavier book, and the new edition became available. The third edition became available last year. And the second edition is available on the website. I couldn't find the third edition. And other books, the second, third, and the fourth. So these are statistical, the books for statistical analysis in R. So mostly it corresponds to the chapter 6 and later for this textbook. So if you feel the explanation is not sufficient in the textbook or the reference 1, then you can refer the second to second, third, or fourth one. At least the second one is on the website. And the R documentations are available in the Comprehensive R Archive Network. So you can access to this website to see some other references. And the course requires a computer with R language and R Studio installed. So if you have not, download and install these two softwares before the next lecture, next class. Yep. And and R is an open source statistical language. So you can download it for free for Windows, Mac OS, and Linux. Yeah, you can access this Chrome website. And R Studio is a kind of an editor. So R Studio makes it more convenient to write and run R code. So if you just want to run R code, it's not necessary. But when you submit homework, you need this R Studio to make more beautiful documents to submit. Yeah, and the R Studio can make Microsoft Word file and PDF file automatically from your code in a beautiful format. And if you want to create PDF format, PDF files, then you need LaTeX installed in your computer. So if you don't use LaTeX software, maybe it's slightly more complicated to install R Studio. But still, I think that you can generate MS Word file, even I think without the LaTeX installed in your computer. And the learning outcomes, so this course have 3 objectives. So one is to use the R language for basic statistical analysis. So coding is the one component. And the second one is to understand mathematical foundation of basic statistical methods. So more statistical theory. So you have taken the Stat 2210 or maybe B2100, but we study statistics in a little more higher level, at a little more higher level. And and the third objective is to choose and implement appropriate statistical methods for real-world data analysis. So once you study statistics, still we have gap between what you studied and the data analysis. So real data analysis is more messy. So for example, it may have missing values, maybe duplicated observations, and that you have to interpret variables to implement more meaningful analysis. So we have the 3 objectives. So this is kind of the busy course because we offer this course in mathematics department. So most of you have stronger mathematics foundation, but you may not know well the statistical computing and also the statistical theory and also data analysis. So it's a little bit busy course. If Wayne State has a statistics department, maybe we can prepare one course for our language and the statistical methods and another course for data analysis, but we have to put everything in one course. So it's a little bit busy course. And this is the lecture link. And lecture video will be available on this website, maybe a few hours later than the class. And office hours, we have different links for Monday office hours and the Tuesday, Thursday office hours. And I will give the quizzes after every class. So 1 to 6 quizzes. Some are multiple choice. Some needs requires you to input some numbers. So you need to code something sometimes. Yeah, so understanding concepts and computer implementation are important to take the quiz. So you need the computer to get the answer. Yeah, work independently while it is okay to discuss general ideas with classmates. And homework will be assigned maybe 1 to 4 times during the semester, and it's assigned 1 week prior to due date. And submit your work as one MS Word or a PDF file created by RStudio in a format mimic to it. So the bottom line is the 2-grade applied statistics homework, it takes time. So I just want you to submit in a good format so that I can grade it efficiently. So yeah, and full credits are given only when your work has a professional level quality. So that means, so you are submitting homework to a kind of hypothetical clients. So you are not supposed to assume that I know everything about the questions. So you have to explain everything clearly. And exam, that there is one take-home exam in October. So work independently, and the exam has usually some applied statistics questions and also some coding questions. And use of AI. So use of AI is not allowed in quizzes, homework, and the exam. So just for training purpose. So yeah. So in final projects, you can use some AI to help coding statistical analysis, but for exams, the exam and quizzes and homework, it's not allowed. And the final project. So this course does not have the final exam, but we have the final project. So in the final project, you are supposed to develop your individual final project plan and collect data and implement statistical analysis and make a 12 minutes presentation. So since enrollment is large, maybe some presentations are turned into video submissions, but I think the most of you can present in class. And probably the students will be divided into 2 or 3 groups, and they watch presentations each other within each group, because we have 30 presentations, so it may be too many. So if we have only 15 students, maybe you watch all presentations, but probably I will divide it into 2 or 3 groups, probably 2 groups. And first, I ask you to submit a project plan that is due on November 17th. And the project plan is a one-page summary of your data and analysis plan. So attach data sample in additional pages or as a CSV or Excel file. So the plan will be returned with comments. So I would like to make sure that everyone is on the right track for the final project. So sometimes students make plan which isn't feasible. Actually, some projects are logically not possible, and some projects are maybe too ambitious as a final project. So in such a case, maybe I ask you to change the plan or modify the plan. I will give more detailed guidance later in the semester. And attendance, I will ask you to attend all lectures because this is 5,000 level and mostly elective classes. Maybe it's required for your major, but you choose that major because you're interested in that major. So attend all classes. Yeah, and if attendance rate is less than 50% as of midterm, you cannot take the midterm, and the attendance less than 50% before November 30th, then you cannot make final presentation. So usually you don't really have to care you have to worry too much about this. But after COVID, some students made very strange requests. They did not appear until the midterm. Then after that, they asked me to postpone the midterm twice or something. So that does not make much sense. So just I put this as a rule. And the grading, the quizzes and homework, 40%, midterm one, 20%, and final projects, 40%. Maybe 5% for plan, 35% for final projects. And the grading scale is this, and the scores for the final projects are 100 at maximum, but only up to 35% of students can get more than 80 points. So only outstanding presentations will get 81 to 100 points. And the excellent presentations will get the 80 points, and good presentations, 60 to 79, and the failing presentation will get 0 to 59 points. And the majority of final projects score 80 or higher in typical years. So, the grading is based on the quiz and homework and midterm, and certainly we have the variability in scores. And final projects, usually everyone works hard, but I still want to give extra credits for outstanding presentations. So if I give 100 for all students, I give all students 100, then that may be fair, may not be fair if the students spent more efforts and made excellent presentations. Right. So midterm and quiz and homework have some variability. So that we want to, I want to, differentiate a little bit for final projects as well. Yeah, and these are important dates. So yeah, take-home exam due the October 24th, and the final project plan due November 17th, and the final presentations, final presentations December 5th and December 7th and 14th. So probably we can put 5 presentations in each of these first 2 dates, and the last day, I think I should put some time, but time is the same. Probably we will have a longer session on the last day. Maybe we may make maybe up to 6 or 7 presentations. So maybe a little less than 20 students can make presentations on these dates. And if more students, maybe some presentations will be turned into video presentations. Yeah, so that's it for syllabus. So do you have any questions? Okay, so Okay, so maybe I will want to have some surveys. At first, maybe I would like to ask, what year are you in? Undergraduate, senior. Well, senior is the majority, and junior. Master's, doctoral. How many people here? 24? Yeah, okay, so 23 answered, so maybe, 27, 26 people. Okay. Okay, and the poll. Yeah, so the majority is senior and some juniors. And the 2 masters, 1 doctoral. Okay, I see. Okay, so I think slightly less graduate students this year. And okay, maybe next question. I'm interested in what you are studying. So I would like to ask your major. Maybe. Oh, sorry, I think it, yeah. Mm-hmm. 18. Okay, so and Paul. So math majors, that actuarial majors, and the natural science majors and engineering. Okay, so some students come from other departments and social science. Graduate students, others. Who are graduate students from data science major or who answered
From
graduate?
physics.
Physics, I see, great. And another grad student?
I think I clicked the wrong
Okay.
choice.
Okay. What is your major?
Public health undergrad.
Sorry?
Public health undergrad.
Public health. Okay, I see, I see. And social science, maybe economics. Who is the social science major? No? Where?
I psychology major.
Oh, psychology. Yeah, psychology. Yeah, yeah. So they use statistics a lot. So yeah, that's a good choice. And yeah, if the course is good, you can ask other students to take 50-30. Okay. And others, the engineering. What is your major in engineering school? I think 4 students answered engineering. Industrial engineering. Who are in engineering majors?
Computer science.
Computer science, I see. Electrical, I see.
Electrical.
Okay, I see. Okay, great, thank you. And the next, maybe I will ask more academic question. So I wonder if any of you have some experience to use R.
What do you count as experience?
Maybe at least you have written some code. Yeah. Something more than calculator. Okay, so 7 students have already had some experience in R. Yeah, so this is basically the course to learn R. So you don't need the prior experience, but the 7 students. I see. And where did you use R? I don't
I
know.
downloaded it and did like 5+7, and that's it.
Oh, okay, I see. Okay, so yeah, okay, I see. Maybe I have to define previous experience more strictly, but okay. And maybe the last question. Sorry. Sorry. I think I got something wrong. Mm. Sorry, I'm not successful to launch the last one. So I wanted to ask you if you have studied Python or MATLAB or a C language. So how many of you have used those languages before? Oh, 1, 2, 3. What language? C?
C++.
Oh, C++, I see.
Python
Python, I see.
and C.
I see. Okay, I see. Yeah, so the R and the Python are kind of similar. It sounds for computer scientists, the Python is more natural grammar. Python has more natural grammar, and the statisticians feel R is easier to use. Or C, C++, and yeah, I see Excel. Okay, thank you. Okay, so that's it for introduction. So I would like to set up the breakout rooms, and I would like you to chat each other, such as your major and the reason to take this course, the why did you choose this course, and also you can discuss other courses you are taking this semester or any plan for the winter break, so anything like that. Okay, so maybe we set up about maybe 6 rooms, and maybe for 5 minutes. After that, I will shuffle the room again and make another breakout rooms. Okay, enjoy conversation for 5 minutes. Do you have any questions? No?
No, I don't have any.
You can join the breakout room.
How do I do that?
I think, I don't know, probably the breakout rooms icon at the bottom. It depends on the interface, but
Oh, I found it. Okay.
you figured it out? Okay. Maybe I will shuffle the breakout rooms and make it again. I don't know if it works. Okay. Recreate. Okay. Okay, so another 5 minutes. Okay. Yeah, I checked the attendance during the breakout room sessions. So just I want to make sure that some people are not here. So Nadir, Akhtar, not here, right? Caitlin, Miazgar, not here. And the Tanganyika, Washington, not here. And the Mick Wimborne, not here. And Assad Atkins, not here. And Andrea Kak and Nicholas Kostakis, not here. Okay, great. Do you have any questions for the course structure or anything about the course?
Can I ask about the grading for the final project?
Grading about final projects, yeah, that's a good question. So I have several criterion. So at first, two components. So one is my evaluation, and another is the vote from other classmates. So if your presentation is most popular among other students, then you are likely to get like 100 or 95. But also I evaluate from the view of statisticians. So at first, the introduction, that is somewhat important to introduce the background of the project to others. And the second is data. So you can download any data from the website, but if you collect data by yourself, for example, even from the website, you go to the first source of the data set, then download it. That's much better than getting data from some data repository. For example, you can go to the United Nations website to get some cross-country data sets for maybe the poverty or some other variables, literacy rate or something. So the data quality is important. And also the statistical analysis, whether or not you use the appropriate methods, and also the how to handle the data. That is another important part. And yeah. And of course, the presentation quality is important. So if presentation sounds boring, it's not good. So at least you have to be enthusiastic about your topics. So probably those are the four most important factors for the final projects.
But what about the cutoff at 35%? Like, can you do more, or
always 35%. So just sometimes I feel that I want to give 100 to all students, but some students did not do well in their midterm, for example, but they did much better in the final presentations. So I would like to appreciate those presentations. So that's why I will give only up to 35% of students the bonus credits. Yeah. So we have to wait for homework and the midterm and final, but actually the most important thing is the wait for standard deviations, right? So even if the maximum is 40, always all students get the 100 in some category, but the students have wide variability of scores in another category. It may not be fair if you spend more time on final presentations. So that's the point. And note that you can get an A with average of, the weighted average of 80, right? So in the final presentation, you get 80. It's usually sufficient to get an A. Yep.
I have a question. Do you have any restrictions on the topic that for the final project, I guess, in terms of what our data set is, or just anything?
Usually the only one restriction is you cannot use the data competition data with the same objective as the data competition. Okay. So because for example, if you go to Kaggle website, that is the data competition website, and you can get the data, but actually a lot of the analysis has been done by other people. So you can almost copy and paste some analysis. So that's why I do not allow you to use data competition objectives for data competition dataset. So if you are interested in some data sets on the data competition website, that's fine, but you have to set your own objective for the analysis. And other than that, you don't really have any restrictions.
Okay.
Any other questions? Yeah, final projects are really your own project. So it's a good experience for you to apply your knowledge to what you are interested in.
Someone has a question in the chat.
Oh, sorry. I didn't. May I ask what is good way to study for this course? How do you expect us to study? For statistical and computer language contents, my slides are self-contained, so you can just review slides thoroughly and also do homework and quizzes. So you do all homework and quizzes, and some quizzes actually, if you implement some code, you can automatically get answers. But just I would like you to understand what's going on. For example, some question asks which code is correct to calculate something. And if you run all of the codes, sometimes you can get the answer. But if you don't think about anything, then you cannot get any knowledge from that. So if you have 4 choices, you can consider which code should be correct. And after that, maybe you can confirm with running a specific code out of all choices. But yeah, so just always I would like you to think about what's going on behind the scene. And yeah, I think that's almost everything you have to do. And yeah, I think that's basically what you have to do. And I will provide some data sources during the course, and also before final projects, I will give some data sources. So you can explore some data source, and you can do some analysis by your own. Then that's probably good. And also, this is the first component includes a lot of coding. So if you make some examples, maybe at first you can run the code on slides. And after that, you can modify it to run slightly different code. So that will help you to get used to our language. And other questions? No. Okay, so I will start the chapter 1. So I will share the screen. And I will use the our language to explain, to demonstrate the code for the first few chapters. But the codes are available. Code is available in slides, so you can see slides. Okay. Yeah, I will discuss some slides here. Then after that, I open the R language to demonstrate some code. Yeah, so chapter 1, basics. So after first 2 chapters, basically you can use R for basic objectives. Okay, at first the introduction. So so download our language if you have not. before next lecture. So installation is pretty easy. So probably it takes only 15 seconds after you downloaded the file. And yes, the R is available for these 3 operating systems. And this is a screenshot of R in Windows. On Mac or Linux, it looks slightly different, but this is a kind of the main console in which you can run code. And this is the window for figure. And maybe another window for help. So some explanation of some functions. So this is the basic look of R. And RStudio is a kind of add-on to R. So RStudio actually the implement calculation by using R language, but the just interface is different. So this is the screenshot of R, almost identical, but a slight difference. So this is the this is the console window, and this is the figures. So we have basically the 2 windows the same as the R language, but we have some additional windows. So here you can write code here. So basically, this is a kind of the notepad for your code. And you can run, for example, code the line 13 and 14 in this console. So if you use the raw R language, probably you have to open the text file to write your code. But in R language, the both are integrated into one software. And here you can see the object you created. If you created the constant C, maybe this is a vector of 2 elements. So you can see what object you have created in R. Yeah. And I will use the R language itself, not RStudio, in my class, but most students prefer to use the RStudio. The reason that I'm using R language itself is it's easier for demonstration purpose. Okay, so yeah, maybe I close this once and I open it again. Yeah, so some disclaimer here, and you can put any code here. So for example, addition, you can just type 1 + 1, then the return key, then you can get the 1 + 1 is equal to 2. The bracket 1, this means this is the first element of the output. Sometimes some outputs have multiple numbers. Oh, sorry. You can do the division or subtraction in this way, maybe multiplication as well. So this is how R works. So it works as a calculator. So sometimes I have to calculate something. Always I open R to calculate something. Okay, so then other basic functions and basic operations. The power function, the 2 to the 3rd power is 8, and square root of 2 is the 1.414. Square root of 100, what's that? This is 10, right? When I came to Wayne State, there is a joke that the 50% of Wayne State University students think that the square root of 100 is 50, but now I think you have much better math knowledge. And 2 to the 1/2 power, that is also square root of 2. And some other functions are included in our language. For example, absolute value. Absolute value of -5.5 is 5.5. You can round numbers by the round function. You can round numbers, for example, 1 digit after decimal point, then we can get the 10th, so 2.9. And yeah, some other functions, such as the floor function. So this round down the number, and ceiling, that this is the round up. So yeah, you can have exponential. You can calculate exponential of 4 by exp of 4. So exp is included in our language. And logarithm, this is the natural log. So if you want to add some explanation, then you can use the pound key. Then after that, these words are ignored when they are run the code. So if I don't include this one, then you got return. So I'll try to calculate log of 10 natural log, but actually this violates the R language's grammar, so it returns an error. And the log base 10 is the log 10. So log base 10 of 100 is 2. Log and exponential are inverse function each other. So log of exponential of 3 is 3, or exponential of log of 3 is also 3. Yeah, you can put more complicated math expressions to calculate more complicated quantities. For example, you want to differentiate the exponential function at x is equal to 0, then yeah, you can calculate this kind of things to get derivative of exponential function at x is equal to 0. Some ready-made numbers, such as pi in R, you can calculate the sine of the pi over 2. Actually, it uses radian, so cosine of the pi over 4, that is the cosine of 45 degree. So that is 1 over square root of 2. So that is 0.707. Yeah, tangent pi over 4. This is the one. So maybe we don't use many functions, but also we have the arcsine or arccosine, arctangent, a tangent, and even the hypercosine, and so on. So many functions are equipped with the base R language. And next, the factorials. The factorials are calculated by this gamma function. So this is actually the 3 factorial. So I would say 4 minus 1 factorial. So this is the 3 times 2 times 1. So gamma function is a more general function than factorial, but traditionally the people use the gamma function. But these days, actually, we have factorial function in R. So factorial of 3 is factorial. Factorial. Okay, so 3. And this exclamation symbol does not work in R. So combination, permutation, probably we don't have any ready-made function. So we have to calculate, for example, if you want to calculate the 7 choose 3, then you have to put this as factorial 7 divided by factorial 3 times factorial 4. So this is 35. There are 35 ways to choose 3 out of 7. Do you have questions so far? Yeah, so you can see slides for these codes. So I think So gamma function is more general function than factorial, and the special case is factorial. So to be exact, gamma function is this. So gamma 4 is 3 factorial. But in general, for fractional z, the gamma function is defined in this way. So all codes are available here. Maybe slightly different here, but yep. Okay, so far we only calculated something what we can do in scientific calculator, but from now on we can do some more complicated things. So at first, assignments. You want to define the many other values, and you can assign, for example, x is equal to 2. So here, after that, you can, if you type x, then r returns 2. For example, x squared, then r returns 4. Maybe x squared plus x, that's 6, and so on. If you also define y, okay, so to define, then you can use this symbol. So arrow, actually, it's actually the inequality sign, but the inequality sign and this hyphen, then you can define x as 2. Then y as 3. Another way to define is just to use the equal sign. So y is equal to 3, then y is equal to 3. Y is equal to 4, y is equal to 4, and so on. So it overwrites. So once you redefine it, this information, y is equal to 3, has been overwritten. So it's not in our session anymore. So you can calculate, for example, x plus y, or 2 times x, 2 times x. Okay, but still, we can do this in scientific calculator. So what's the benefit of using R? So that is, we can use the vectors and matrices in R. So that is the most significant difference from scientific calculator to R. So for example, that we want to define the weight of 5 babies. Weights of 5 babies in one object, then you can create like this. So we have 5 numbers, 3.1, 3.9, 4.3, 2.5, and 3.6. So we have 5 numbers. So we want to make a vector with these 5 elements. Then you can put these numbers separated by a comma. Then you put the C and parentheses, and also parentheses here. Then weight is a vector of these 5 numbers. And this is the first element, and the second, third, fourth, and fifth. Yeah, you can define also another vector, for example, vector of heights of 5 newborn babies. Suppose the first baby has the height of 0.5 meter, and the second baby has the height of 0.54 meter, and so on. Then you can define this way. Then, for example, okay, so weight is in kilogram and height is in meter. And if we want to calculate the body mass index is, weight divided by height square. So based on body mass index, we can judge whether those babies are overweight or obese or something like that. And that is weight divided by height square. Then you can get BMI of these 5 babies at the same time, so at once. So you can see 3.1 divided by 0.5 square is 12.4. That comes here. And for second baby, the 3.9 divided by square of 0.54, so that is 13.37. So we can calculate this at once. And obviously, this is useful in statistics. So we have data with 100 observations. Maybe we can import the data set from some Excel file or CSV file. Then we want to calculate BMI for all babies. Then you can just type this, then you can automatically calculate BMI for all observations.
Professor?
Yeah.
I have a question.
Sure.
So is the C denotes a vector,
Yes,
correct?
C declares a
Okay.
vector, yes.
Okay.
Yeah, so BMI. Then sometimes we want to pick up just the second element of this object. So in such a case, you can type BMI bracket 2. So this returns the second element of BMI. Or you can type BMI. Okay, so we can define the number sequence by the starting number and the ending number and the colon here. Then this becomes 224. So if you type BMI 224, then you can get these three numbers. Or if we want to get the first element, 12.4, and the last element, 13.84, then you can type BMI C15. So remember that this C declares a vector of 1 and 5. So then we can extract the first and fifth observation of this BMI. Yeah, maybe some other functions such as BMI -5, then all observations except for the fifth observation. Yep. Do you have any questions so far? I think the today's quiz includes assignments. So assignment needs either this symbol or this symbol. X is equal to 2, and actually we will study this later, but this is the logical operation. So whether the R returns that whether this statement is correct or not. X is 2, so X is equal to 3 is false. Yeah. Okay, so now maybe once again, the weight, we have 5 numbers. If we want to take summation of these 5 numbers, then we can do this. So some functions work on vector, not just a number. Summation and the length of weight. We have 5 elements, so 5. So it's almost obvious, but if we have so many observations and we cannot really see all observations on screen, then this is a useful function. So of course, the summation divided by number of observations is average. So you can calculate the sample mean in this way, but also you can calculate sample mean by mean function. In Microsoft Excel, this function is named average, but usually statisticians use the word mean, instead of average. Okay, so any questions? No. Okay, so the next one is, I will use some slides. So variance and standard deviation. So the variance of X is defined in this way. So suppose we have n observations, X sub 1 to X sub n. Then the sample variance is defined by 1 over n minus 1 times summation of this xi minus x bar, the square of this. Yeah, so that is the variance. So at first we have to calculate the x bar, then we have to take the deviation. So basically the difference between xi and x bar for each I, then take square and take summation. So that means that basically this is the average of square of xi minus x bar. and this is distance. So this is a kind of the average squared distance from the center. So if these observations have wider variability and many observations are far away from x bar, s sub x square is larger. And if the most x sub i's are very close to x bar, then s sub x square is smaller. So this is the sample variance. Yeah, we take square. We have some reasons, but yeah, we will discuss it later. But yeah, if we don't take square, the positive deviation, the highlighted part is called deviation. Positive deviations and negative deviations cancel, and always this becomes 0. So it does not make sense. So that's why that we have to take the square. We have to take square of the deviation. So this is a kind of the average squared deviation. So we have n minus 1, not n, in the denominator. So we have some reasons. Maybe you can say that think about the situation that n is equal to 1. We have one observation, just xi. Then we cannot evaluate the variability of the data set because we only have one observation. Right? If we have the one observation, we cannot evaluate the variability. If we only have the temperature on one day, we cannot really see the temperature variation. Yeah. So, but if we use n in denominator, as a denominator, then actually the s sub x square becomes 0. Because, okay, so if n is equal to 1, we only have x1. The average is also x1. So if we subtract 0, then summation is 0, then 1 over 1. So that is 1. 1 times 0 is 0. So s sub x square is equal to 0, right? So, but with one observation, we should get the answer that we cannot evaluate the variability, right? So if we get 0, that underestimates the situation. So that's why we have to use something different from n. So that is one reason that we have n minus 1 here. Maybe another way to put it is, suppose we have 10 observations and we calculate x bar, but the x bar depends on these 10 observations. So actually, if we calculate the difference between xi sub I and x bar, it actually underestimates the quantity for difference between the true center and the xi. I mean, population mean and xi. So usually we want to calculate the distance between observations and the population mean, but we don't know the population mean. So we have to use the sample mean here to calculate deviation. So that underestimates the situation a little bit. So to compensate that we put n minus 1, slightly smaller denominator than n. And sample standard deviation is the square root of the sample variance. So square root of this. And actually, the variance has the very strange unit. Suppose that the xi is in kilogram. So the unit for xi is kilogram. Then what's the unit for s sub x square? Then we take square here, right? So the unit for variance is the square of kilogram. But the square of kilogram does not make sense. Right? So if we take square root, then that is more natural quantity. Actually, it has the same unit as xi. So that's why it's usually easier to interpret the sample standard deviation rather than sample variance. And the code is here. So weight is the previous function. And maybe, yeah, I can type that the variance of weight, then we can get the variance. And yeah, also we can get, for example, we can take the difference between weight and the mean weight. Okay, so mean weight is one number, but if you calculate the vector minus one number, actually it calculates each element minus this number. So this is again a vector of with 5 elements. So weight is vector, mean of weight is just one number, but the difference is actually again the vector of 5 numbers. Then take square. Take square means component-wise square. So square of first element and so on. Then take summation, then divide this by n-1. We have 5 observations, so we divide this by 4. Then we get the variance, so we get the same answer. And standard deviation function is here, so we can also get standard deviation. Yeah, so that's it for today. And I will give, I think, the 2 or 3 quizzes. I think 3 quiz questions after lecture. Do you have any questions?
I have one question.
Sure.
So when you're assigning a variable, when you initially assign it, does it always have to be with the arrow, or can you use the equal sign initially too?
To assign?
Yeah, so if you're assigning a variable.
You can switch between 2 symbols at any time. Yeah.
Okay.
So it looks a little bit messy, but yeah. Okay.
I have a question about the quizzes.
Sure.
On Canvas, there's 3 assignments, but they have a due date for 2021.
Yeah, actually, it's on the way to make it.
Oh,
So I just imported some quizzes from last year, maybe 2 years ago. So I will fix it. So yeah.
Okay, thank you.
Okay. So if no questions, just yeah, that's it for today. So see you on Thursday. Okay. Thank you.
Have a good day.
You too.